Sir, shall we start the meeting, sir?
Yes, sir. Yes, sir. Please.
I'm down, sir.
Yes, sir. Yes, sir. Please.
ACCE Kakinada Center Chairman Badam Sundara Garu, Managing Committee members, all the participants, ACCE members, student participants, builders, engineers. Today's speaker, Krishna Reddy Garu. Good morning to all. It's my great pleasure to introduce an accomplished technology leader and visionary entrepreneur, Engineer Krishna Reddy Kovvuri. He is also founder and managing director of Krify, a global technology software services company that specializes in mobile applications. A fellow member of Institute of Engineers and chartered computer science engineer, Engineer Krishna Reddy has worked with several prestigious companies, including Mentec, ISMA Switzerland, and Applied Materials in Santa Claus, USA. He holds an MTech in Computer Science Engineering with a 1 year of special in Poetic Computational Neuroscience Lab, Department of Computer Science, IIT Kharagpur. His industrial focus includes digital informations using emerging technologies such as AI, ML, blockchain, and cybersecurity. Engineer Krishna Reddy is also passionate about rural IT development, and he has established a state-of-art of development center in Smart City Kakinada in Andhra Pradesh, with, which accommodates up to 500 employees to work along with their Bangalore facility. Under his leadership, Krify is registered in India, the UK, and USA and services its 1,000 plus global customer base with mission critical software solutions and applications. In addition to his work with Krify, Krishna is also actively involved in promoting technology entrepreneurship in India. He has mentored many startups in the country and has been valued resource for entrepreneurs looking to build successful technology companies. Now I welcome Engineer Krishna Reddy Garu to start his session on building information modeling, which is useful to our civil engineers. Welcome, sir. Sir, please unmute, sir.
Thank you, sir. Good morning, everyone. I feel very privileged to interact with all the senior, young, and vibrant members of Association of Consulting and Civil Engineers, ACCE, and the friends. I wish to thank Engineer Badam Sundarao Garu and Durga Prasad Garu and others for inviting me to address this August gathering today. My name is Krishna Reddy Kovvuri. I'm CEO of Krify. We are a global technology, mobile, and software development and IT solutions company. So in Krify, we specialize in providing innovative digital solutions to businesses across various industries, which also includes AEC industry. So our team of experts is dedicated in developing cutting-edge solutions that help our clients achieve their business goals. In the construction industry particularly, we have been working closely with clients to improve BIM and other digital solutions that enhance the collaboration, improve efficiency, and reduce errors. We have also developed websites, applications, and digital infrastructure solutions. So today I am excited to talk to you all through this Google Meet about important topic in the construction industry, which is BIM, which is also called building information modeling. So as we all know, construction industry is a very vital sector of the economy. So it creates jobs, drives economic growth, and provides essential infrastructure for communities around the world. However, it's also an industry that faces many challenges, including very tight budgets, tight schedules, and high risk. So this is where BIM comes in. BIM is a digital tool that enables architects, engineers, and construction professionals to plan, design, construct, and manage buildings and infrastructure more efficiently and very effectively. So by using BIM, stakeholders can create a very detailed virtual representations of the projects, analyze and optimize every aspect of the project, and reduce errors and rework. So today I want to present an introduction to the BIM. BIM is a very big subject, and the latest advancements in BIM is what I'm going to focus on. I'm not focusing too much on the implementation part. So we'll be exploring how BIM is transforming the construction industry and some of the latest technologies that are being integrated into the BIM and the potential of BIM for the future of the construction. So I believe that BIM is an important tool for the construction industry, and I hope that by end of this presentation today, you will have some understanding of the BIM. Maybe some of you have already known BIM and maybe using BIM, but primarily this is a kind of a brief introduction and how it is helping AEC industry. So thank you very much for joining me today, and let's get started. So before we jump into BIM, let's also focus on some of the challenges. So prior to introduction, so this AEC industry, the architecture, engineering, and construction industry has faced many challenges in managing construction projects. These challenges can be broadly classified into three categories: the communication challenges, and collaboration challenges, and information-based challenges. So let's discuss each of these challenges in little more detail. So the communication challenges, communication is a very critical aspect of any construction project. The AEC industry faced several communication challenges prior to the adoption of the BIM, and these challenges we can put it as fragmented communication, which means communication channels between stakeholders were often fragmented, with the different stakeholders using different communication methods. This made it difficult to ensure that everyone is on the same page. Again, miscommunication. So it was common as stakeholders often had different interpretations of design drawings and other project information. So this has also led to costly errors and rework. So time constraints are also an important aspect in this regard. So the second one after communication challenges is the coordination challenges. As coordination is critical in construction projects, as different stakeholders need to work together to achieve common goal. However, prior to the BIM, the industry faced several coordination challenges, which includes lack of transparency. For example, coordination was often hindered by lack of transparency as the stakeholders did not have access to same project information. Again, incompatibility, different stakeholders use different softwares, file formats, which made it difficult to share and integrate project data, and limited collaboration. So collaboration between stakeholders was often limited, with different stakeholders working in isolation rather than as a project team. So the third one is the information management challenge, which is also critical in construction projects as stakeholders need to access accurate and up-to-date information to make informed decisions. However, prior to the adoption of BIM, the AEC industry faced several information management challenges. Some of them includes, again, limited information, because information was often limited to 2D drawings, which was not providing a comprehensive view of the project. Lack of details, again, design drawing often lack the level of details that are required to coordinate complex building systems and construction details, specific details, and also limited data integration. For example, project data was often soiled, it is siloed, so which made it a bit difficult for different types of data into a very comprehensive view. So that's when we have the CAD. As CAD stands, computer-aided design. So it refers to the use of computer software to create two-dimensional and three-dimensional models of the products or the structures. So CAD was introduced in the industry in 1960s. It is not something very new. In fact, quickly it became the primary tool for design and documentation. CAD solved many of the challenges faced by the AEC industry at that time, which also includes the communication challenges we discussed. For example, CAD allowed creation of digital drawings, which made it easier to share and distribute the design information. These coordination challenges, stakeholders work on the same digital model, information management. CAD also allowed the creation of 2D and 3D drawings, which were more easy to share. So, however, in spite of CAD solving some challenges, CAD has several limitations, which made it difficult to manage complex construction projects. Some of the limitations of CAD includes limited visualization, which means CAD was limited to 2D and 3D drawings, which made it difficult to visualize and coordinate a very complex building system, which have multi-layered complexities include electrical and structural, different divisions in the construction details. Again, fragmented data. CAD files were typically created in isolation, which made it difficult for the different stakeholders to collaborate and coordinate on a project. Limited data integration. CAD was primarily used for the design and the documentation, so which meant that it did not provide a very comprehensive view of the construction project. So this made it difficult to monitor the progress of a project in real time and identify potential issues early on. Again, the fourth issue is the incompatibility. So different stakeholders often use different softwares and file formats. Again, low transparency, which means CAD models were not very easily accessible to all stakeholders, which made it very difficult to ensure that everyone was working towards the common goal. Okay, so that's when we have BIM. So this sets to understand what is BIM. So BIM is building information modeling, so which is actually a process. It's in fact a process that involves creating and managing digital models of the buildings and infrastructures through, which means throughout their life cycle. Which means BIM is a very intelligent 3D model based on, which is a very intelligent 3D model process that provides professionals very insight and tools that effectively plan, design, construct, and manage buildings and infrastructure. So BIM is important in the construction industry because it allows for better collaboration, coordination, and communication among all the stakeholders involved in a construction project. It also allows for a very more efficient and accurate approach to designing, constructing, and managing buildings and infrastructures. So what are some of the benefits of BIM? So BIM increases the efficiency. So BIM helps reducing the waste, rework, and delays by allowing stakeholders to actually work together coordinatedly in real time and identify issues little early on. So this way, it actually leads to cost and time saving. Whereas the number two is actually improved collaboration. So as it is mentioned, BIM actually encourages the collaboration between different disciplines, the stakeholders, and then it actually promotes the team to approach the construction project in a more systematic manner. So enhanced visualization, BIM provides a more comprehensive view of the project. It actually gives a more comprehensive view of the project, allowing all the stakeholders to actually visualize, coordinate the complex building systems and constructions very detailed. The fourth one is better decision making. BIM provides stakeholders with very accurate and most up-to-date project data, enabling them to make very informed decisions and coordination. And finally, the sustainable design. BIM actually allows stakeholders to plan, evaluate the environmental impacts of the buildings and the infrastructure projects and explore sustainable designs and options. So how all this happens, because BIM works by actually creating a digital model of the project. They also call digital twin that contains all relevant information, including architectural information, structural information, the electrical and mechanical information, plumbing information, etc. So these BIM models, particularly the BIM model, is actually a centralized repository of the information that can be accessed and updated by the all stakeholders involved in the project. So BIM includes various features and capabilities. For example, compatibility. BIM software is designed to be very compatible with other softwares used in the construction industry, and it has interoperability, which means it can work with other sources and other disciplines, etc., across all the stakeholders. It helps coordination well. BIM enables stakeholders to actually coordinate their work and identify problems and issues quite early, and this actually reduces the waste and rework. And then the centralized model, BIM actually provides a very centralized repository model of the project, so that can be accessed and updated by all stakeholders, ensuring that everyone has access to the same information. So the final approach is actually visualization. So BIM actually provides the stakeholders with a visual representation of the project, allowing them to better understand and coordinate complex building systems and construction to very detailed extents. Next is BIM dimensions. Just 1 second. Now, as I mentioned, CAD and CAM focused majorly on 2D and 3D. BIM has a multi-dimensional model. Actually, BIM dimensions refer to different levels of information that can be integrated into the BIM model. So these different dimensions range from 1D to 8D. Each represents a digital level of the information that can be used in the construction industry. Each dimension builds upon the previous one, resulting in a more comprehensive and detailed model. BIM dimensions help improve communication, collaboration, and actually decision making throughout the entire construction process, from design and engineering to construction and operation. Finally, design, engineering, construction, and operation. So let's actually go into these dimensions very quickly and discuss them. The first one is 1D BIM. This includes using a database to create a list of buildings, particularly building components and their properties. For example, a 1D BIM model may include a list of building components such as walls, doors, windows, and their respective properties such as material, dimensions, and quantities. So this information can be used to generate cost estimates, material takeoffs, and bills of the materials. The second one is the 2D BIM. This involves creating a 2D representation of the building components, such as floor plans, elevations, and sections. For example, the 2D BIM model may include a very detailed floor plans that can show the layout of each room, the location of the doors, windows, and other important details. So this information can be used to communicate design intent and also provide a very detailed view of the project. So subsequently, the actual dimensions are 3D BIM. This includes creating a 3D model of the building components, such as the walls, roofs, and the foundations. For example, this 3D BIM model may include a detailed 3D representation of the building that allows stakeholders to visualize the project and coordinate complex building systems. This information can be used to identify potential clashes between building systems and plan construction sequencing. Okay, the subsequently next one is 4D BIM. This actually involves adding a time element to the 3D model. So allowing stakeholders to visualize the construction sequence and plan the project timelines. For example, 4D BIM model may include a very detailed construction schedule that shows when each building component will be constructed and installed. in time. So this information can be used to optimize construction sequencing, improve communication, and reduce construction time. The next one is 5D BIM. So this involves adding cost information to the 3D model, allowing the stakeholders to evaluate the cost and make informed decisions. For example, a 5D BIM model may include a very detailed cost estimates that shows the cost of each building component, including the labor and material cost. This information can be used to evaluate different design options, optimize construction sequencing, and reduce the project cost. So generally, these things will happen with the intelligence of the engineers, but these models actually provides a systematic approach in reaching the same. So the next one is the 6D BIM. This involves adding sustainability information to the 3D model, allowing stakeholders to actually evaluate the environmental impact of this specific project and explore sustainable design options that are involved inside. For example, a 6D BIM model may include a detailed information about energy performance of the building, including energy consumption, carbon footprint, and the potential savings from the sustainable design options. So this information can be used to optimize building performance, reduce energy cost, and improve particular sustainability. So the next one is 7D BIM. This involves adding facility management information to the 3D model, allowing stakeholders to actually use and manage and maintain the building or the infrastructure construction. So until the construction completes. For example, as it is mentioned on the slide, a 7D BIM model may include a very detailed information about the maintenance requirements of each building components, including its schedule, costs, and life cycle analysis. This information can be used to optimize the facility management, reduce, particularly reduce maintenance cost, and extend the life of the building. In one of the cases that we have worked with one of a UK-based dental green building, particularly they have in their scenario, they have different units, not only the building components, but they also need to do regular CQC audits. So actually this model actually includes those plans also within the 7D BIM itself. Whereas the 8D BIM involves adding safety and security information to the 3D model, which actually allows to evaluate the safety risks and plan security measures. In 8D BIM model, particularly if you see it as an example, it includes very detailed information about the fire safety, security cameras, the emergency response plans in the event of any issues such as a fire or a chemical leakage, etc. So this information can be used to improve the safety and security, reduce the risk, and ensure compliance with the safety regulations. So how all this happens? So what is BIM workflow? The typical workflow for a BIM project involves several stages that requires collaboration and communication among different stakeholders. Here is a general, you can see the chart. Here is a general overview of the BIM workflow and how the stakeholders work together throughout the project lifecycle. Project initiation, particularly in this stage, the project team is assembled and the project goals and scope is very well defined. The stakeholders involved in the stage may include clients, architects, engineers, and construction manager. The second is actually a conceptual design stage. So in this stage, the design team creates a concept design that actually meets the project requirements. The stakeholders involved in the stage may also include architects, engineers, and interior designers. And the third stage is a detailed design. So in this detailed design, design team creates a very detailed design that actually incorporates all the necessary building components and systems. So the stakeholders involved in this stage may actually include architects, engineers, MEP consultant, and also structural engineers and the contractors. And the fourth one is the construction documentation stage. So in this stage, the design team actually creates the construction documentation that includes design drawings, specifications, and schedules. So the stakeholders involved in this stage may include architects, engineers, contractors, and subcontractors. And the fifth one is construction. In this stage, the building components are constructed and installed according to the construction documentation. So the stakeholders involved in this stage may include the contractors, subcontractors, and the project managers. So the sixth stage is facility management. In this stage, the building or its infrastructure is operated and maintained throughout its life cycle maintenance phase. So the stakeholders involved in this stage may include the facility manager or the owner or the maintenance staff. So throughout the project life cycle, collaboration and communication are essential to ensure that the project is delivered on time, on budget, and to the required quality standards which is being mentioned or specified. BIM actually enables stakeholders to collaborate in real time, share their data, and work together to solve these problems. For example, during the design stage, if the architect and the engineer may collaborate to optimize the building performance and reduce costs, during the construction stage, the contractor and subcontractor may actually collaborate to plan the construction sequencing and coordinate the building systems. So in the facility management stage, the facility manager and the maintenance staff may actually collaborate to optimize building performance and reduce its maintenance cost. So effective collaboration and communication in BIM workflow can actually help stakeholders to identify and solve problems early in the project life cycle, which actually reduces rework and improve the project outcomes. It also helps to ensure that all stakeholders have access to the most up-to-date project information, reducing the risk of errors and delays. Overall, if you see, BIM promotes a very collaborative and very integrated approach to building design, construction, management, and improving the project efficiency, which actually reduces the costs. So at this stage, let's look into few software tools or the classification of the software tools. BIM actually, BIM software tools and technologies enable the creation of a very detailed digital representations, are also called digital clones, that integrates multidisciplinary and data to support overall collaboration and taking decisions, decision making, and finally saving costs. So overall, if we see BIM software tools and technologies can be broadly divided into following ways. For example, the design authoring tools. These design and authoring tools, particularly if you classify, design and authoring tools includes our the most popular Autodesk Revisit and ArchiCAD and this Bentley system. Particularly Bentley systems enable designers to create the 3D models that actually contain all the information required to construct the building and infrastructure projects. These tools includes overall functionality for creating the architectural and structural, mechanical and electrical and plumbing systems, as well as generating the overall construction documentation. And the second one is the first one is the design authoring tool. The second one is actually the collaboration tools. Collaboration tools includes BIM 360, Navisworks, another one is Solibri, so which is also enables the stakeholders to share overall project data and also review the various design changes while the project is actually ongoing, and collaborate these details in real time. So these tools include functionality for managing project timelines, overall tracking of the projects and their issues, and generating finalized reports of the system. Okay, and the third set of software tools includes visualization tools. These tools include Enscape, Lumion, and then Twinmotion. These tools actually more of a visualization side, which enables the stakeholders to visualize and simulate the project design in 3D. These tools includes functionality for generating very photorealistic and particularly photorealistic images which renders and they create visually, astounding walkthroughs and performing, particularly performing lighting and shadowing analysis, etc. So this actually helps in overall analysis of the visualization before actually the construction process. So finally, the analysis tools. Analysis tools are Autodesk Insight, also IES, Energy Plus. These tools enable the stakeholders to analyze building performance data such as energy consumption, lighting levels, and thermal flows and thermal comforts. So these tools actually include functionalities for performing energy simulations, daylight analysis, and thermal analysis. So interoperability are the open standards, which is also critical to the success of the BIM process. Particularly different software tools. When you have different software tools, interoperability refers to the ability of different tools exchanging project data seamlessly. So actually open standards are required. So open standards are technical specifications that ensure software tools can actually exchange data. There are things called APIs. So these data should have common structures so that they can easily exchange each other in a very standardized format. So the adaptation of open standards and interoperable structures ensures all the projects and stakeholders have access to the same project data and reduce errors and improve their collaboration. Okay, so that being said, let's also explore few latest advancements in BIM. Actually, like all the industries, BIM actually has come a very long way since its inception, and the latest advancements, particularly in the cloud computing, artificial intelligence, machine learning, IoT, are further revolutionizing the industry. So in this particularly, let's first explore the IoT. And now mostly you know that the Internet of Things has revolutionized. It's actually a connected network of devices, which means devices speak like humans. That's how it is being perceived. It can actually collect data, share data. In BIM, IoT devices can be used to collect data about the building performance, its health, and its temperature, and then humidity of the building or the room, and how much is actually the energy being consumed. There are tools like LoRa Gateway. These are actually specific protocols. They actually very efficiently, in an energy saving manner, they actually share this information. This data can be used to actually optimize the building's overall operations, reduce energy consumption, and improve the indoor air quality, etc. The second technological advancement that is coming is also the cloud computing. Cloud computing actually allows the storage and processing of a very large data in the cloud rather than on the local servers. Since my engineering in year 2000, 2002, artificial intelligence is there, machine learning is there, regressions and all these mathematical concepts were there. What was not there is cloud computing. So it actually, what it actually means is it allows us to actually save our data on the cloud. We can define how much we want. It's not a fixed size. You can expand and you can contract. So BIM, so cloud computing allows for the creation of a very centralized model that can be accessed by the all project stakeholders, which is at a central place. So there is no link to the specific location. So this central model, or the central repository model of the BIM, actually allows a real-time collaboration, reduces errors, and improve the project outcomes. So after cloud computing, the significant latest advancement is the machine learning. Machine learning is actually a subset of the artificial intelligence, which I explain next. So machine learning actually uses primarily maths algorithms to learn about data. Machine learning is the mind. It goes through the data. There are different types of machine learning techniques which are available. So they actually make predictive analysis or decision-making systems. They actually understand the data, reinforcement learning, different types of learnings are involved. So in BIM, machine learning can be used to actually automate very tedious and repetitive tasks, such as clash detection and then model validation. This actually allows the faster and more accurate model generation, reducing project time and the costs. And most interesting and intriguing is the artificial intelligence. We are actually heading the tsunami of artificial intelligence. What we are seeing now is a tip of the iceberg. So artificial intelligence technology is similar. In fact, machine learning is a part of artificial intelligence, but it's actually focuses on creating intelligent machines that can actually simulate human intelligence. So in BIM, AI can be used, or AI is used actually to analyze and optimize the building designs, self-learning, optimizing energy consumption of the building, learning from this data, and analyzing the overall data patterns and things like that. So this actually allows creation of very sustainable and more efficient buildings. And finally, the importance of collaboration and efficiency. So these advancements in BIM technologies are actually transforming the way we use actually BIM by improving collaboration and increasing efficiency in the construction projects. The use of IoT devices or the cloud computing or the AI and machine learning allows project stakeholders actually to shake their hands and collaborate in real time, regardless of their location. So this real-time collaboration reduces errors, improves project outcomes, and reduces project times and actually costs. So with that being said, very quickly, let us go through some of the case studies of the projects. BIM has a very significant impact in the industry with these examples. Specifically, the first one is shared London. You can see the picture there. This is actually in a very iconic building in the central London. That was actually one of the first high-rise building designed and constructed using BIM. BIM allowed the design and also the construction teams to actually collaborate in very real time. It reduced errors and improved overall efficiency of that building. So particularly using BIM allowed optimization of the building and also resulting in overall energy saving for it. And the next one is this the so-called Zhuhai Macau Bridge, which is also one of the popular and iconic bridge in Hong Kong. It's the longest seaside bridge. I mentioned the picture there. Spanning nearly 55 kilometers. BIM actually used for the construction design of the bridge, which allowed the design and construction teams to collaborate in real time. And then the next one is one Vanderbilt bridge in New York City. It's actually a 1,401 feet. It's a skyscraper in the New York City and also was designed using the BIM in its background. Subsequently, the other one is Barcelona Metro Line. Barcelona Metro Line is actually a subway line in Barcelona. It is also designed and constructed using BIM. It helped overall productivity. And then subsequently, One World Trade Center. It's also in New York City. It's a prime example of how BIM technology can be used for construction and streamlining of the overall process. This project used, as I mentioned there, used a 3D BIM model to coordinate over 20,000 unique parts and over really 100,000 tons of steel, resulting in a very high and efficient, like a very efficient and safe construction process. So the BIM model also allowed for real-time collaboration. So the next one is very popular Burj Khalifa. So Burj Khalifa in Dubai, it is actually very tallest building. Is also another example of how BIM was actually used. And the final one is Laxton Bradley Terminal. It's actually in Los Angeles, California, which is also a classic example of how latest advancements have been used, including IoT and cloud computing. Okay, and finally, particularly the Manchester Engineering Campus is also another example of the classic BIM development in UK. UK government actually it was also the early adopter of BIM. In fact, when statutory BIM was used, UK is the first government which actually come forward and actually started telling that in all government buildings BIM should be used and things like that. And a very quick brief, even though I don't want to touch in this session on the BIM implementation. Implementing BIM is actually a daunting task, which means it's a challenging, intelligent task. But there are two key strategies that can actually ensure a successful implementation, which means the first one is actually creating an effective BIM vision and managing change during the transition. So as I mentioned on the slide, to create a very effective BIM vision, your firm actually needs to identify goals and objectives for using BIM, why we are using BIM. Those goals should be aligned with the overall business strategy and also should address the specific needs of the organization. BIM vision should also clearly define the expected outcomes of using BIM, including the improved efficiency, reduced cost, and better collaboration among all the project stakeholders. The second one is actually managing the change during the transition, because managing change during the transition to BIM is very critical, particularly in ensuring its successful implementation. Let's quickly go through some effective BIM implementation, particularly what is the steps that are actually required. The first one is conducting a very thorough analysis of the organization's goals and objectives, and also develop a very clear and concise BIM vision and define expected outcomes using BIM and develop a clear roadmap for achieving all the outcomes, and communicate the BIM vision and roadmap to all the stakeholders, including the contractors, clients, and also the employees of the organization. Identify the potential impacts of BIM and also developing a plan for managing those impacts, and providing a very adequate training and support to all the employees. And also another point is monitor and evaluate, which means maintenance. BIM is to ensure that that we achieve desired outcome and make positive impact on the organization. So by following some of these steps that I have mentioned, actually firms can actually create a very effective BIM vision, manage change during particularly during the transition, to ensure a successful implementation of BIM will happen. So this will help organization to realize the BIM benefits, including efficiency, reduction of costs, and better collaboration. So yeah, so what is the future of BIM? How things can go in the future? So the future of BIM is very promising, as some of these emerging technologies that I have mentioned, particularly the AI, VR, 3D printing, blockchain, and some of these examples are there. So which are actually improve the efficiency and collaboration of the construction projects in the future. The first one of such impact is with the virtual reality. Particularly the virtual reality technology can actually create simulated environments that can actually, so people can actually experience not just seeing the 3D models, but they can experience and walk in those models. In fact, they actually immerse inside the design that is going to be developed. So VR actually can be used BIM to create these immersive and interactive experiences, allowing these real stakeholders to feel and experience the building designs quite before it's being built. That actually reduces a lot of challenges and issues, which can identify several issues and improve proper communication and reduce project cost and overall performance. And then the second one is actually the augmented reality, or AR. AR and VR. AR actually enhances what we are seeing. VR actually immerses into the another world. So augmented reality is actually a combination of both enhancing the visuality. So BIM actually uses it effectively for the construction process in the future. AR technology overlays the digital information in the real world, which allows the stakeholders to actually view the designs in the real world context. This can actually help the overall potential issues and then collaborate well. Okay, after augmented reality, the most effective technology, I think a lot of people, I mean, you can see a lot of YouTube videos where it actually tells that a 3D model based building was built and things like that. So these 3D printings have already been mentioned in technologies, and then even YouTube and things. So it can actually help prototyping, not just prototyping, shoot costing, things like that, but also generating the needful components, but and also create the entire structures. So this is another future good impact. Also, my actual favorite, crypto blockchain. Actually, blockchain on a very top level is actually a digital ledger technology, open ledger technology. I hope it's not too complicated. There is a cryptographic technologies such as a SHA-256, MD5 encryption decryption techniques. For engineers, it's very clear. So if you take a string, you can actually encrypt it and then you can decrypt it. The tools like SHA-256 and MD5 actually generates one-way encryption, which means you cannot decrypt them back, however hard you work. So there are something called hash sheets. So blockchain is another open ledger technology. It consumes a lot of computing power, with availability of cloud computing, you can still avail. BIM actually has a good potential using blockchain. That way, the building collaboration, even governmental involvement, also how this building is being developed and things like that. If it is in blockchain, it cannot be tampered. So that's about blockchain. So yeah, I think overall these all emerging technologies have potential to significantly improve the efficiency and collaboration of the construction projects. So overall, by integrating all these futuristic technologies into BIM and BIM workflows, project stakeholders can actually work together more efficiently and effectively, leading to a better outcome and building a more sustainable building environment, environment here. That's all, and I want to thank you, all of you, for patiently listening, and then I hope this could have been a little bit helpful to all of you. Sir, that's all my presentation. Handing over to you, sir.
Thank you, Krishna Reddy Garu, for your introduction about BIM. Actually, this is an introduction to BIM only, and the detailed information about BIM is it's a vast subject, and if our members are interested, we will plan weekend program or every Sunday for 2 hours, or either physically or on online mode. We can plan so that it will be highly useful for all of us. In few of our projects, we have used this BIM and we got benefited. Actually, what happens? Electrical people, they make their drawings. Plumbing people, they make their drawings. 5 people, they make their drawings. If they all are collaborated together, definitely at some places they will overlap and they will affect each other. All these things, what happens if the work is executed without having this management skill? What happens? They will overlap, or at that in the site we have to make some alterations. Sometimes which may hinder each other, and sometimes they may cause several problems. To avoid such things, BIM modeling is very, very important, and which we should learn for ourselves, and by that our clients will get benefited, and moreover the quality of work or our performance will improve abnormally. And if all members are interested, please put their interest in the group, so that we'll plan for a course on BIM in the weekends, so that without disturbing our regular schedules, we can learn a new technology, new technique, and we all can get benefit of it. Thank you very much, Krishna Reddy garu. And now I request our members to ask any questions on the subject.
Sir, one person posted he is interested, Kalyan J.
Interested in learning?
Interested
Yeah,
in what you told the course, sir, weekend course,
Yeah.
you told us, sir.
Yeah,
Immediate
definitely,
response is
definitely.
received from Kalyan.
Yes, sir.
One more person, sir.
Yes, sir.
Yes, sir.
Yeah, if we get about 20 to 25%, definitely we'll check out with some professionals of this field, and we'll take advantage from it.
Sir, sir, there is one message posted in the chat by Mr. Krishna Prasad garu, Crisp Interiors and Architecture. Krishna garu, I mean, as mentioned, Revolt is one big software which I have seen is getting as a quite popular. This is actually quite evolving subject. So particularly for us, we've developed a custom cloud-based collaboration tool, not as broad as the structure I have mentioned now. That model actually tried to collaborate the overall facility management and alert system for regular maintenance and things like that. We are also learning and implementing these tools. In future, maybe when we get to a confidence to show a significant project, we'll actually show it, sir. But at this moment, I don't have any project to actually share it with you readily.
Hello, sir. Hello, sir.
Hello,
I have one question, sir.
Krishna Reddy.
Sir,
Yeah, you can ask.
Please, please.
Right, sir. This is Dr. Narasimha, sir. Thanks for your nice presentation.
Sir,
I have two questions to answer. One is regarding the 3D printing. Can we expect in a future in a large scale implementation the real-time projects at a small level?
Sir, I strongly feel this technology is not, I mean, we are not yet fully, it's like EV, electrical vehicle kind of a technology, sir. Significantly, the future would be using, EV in cars and other area, and 3D printing, because it reduces the efficiency, it increases the efficiency and reduces the cost, sir. I personally feel we are at the starting stage of this field because we are not really confident fully, or that's one of the reasons we were not able to fully implement. But I personally feel 3D printing is going to be very significant in construction industry, sir.
Yeah. One more question, sir. Second question. This is regarding the implementation of the rebar detailing, 3D rebar detailing in the construction projects. One of my client insisted this 3D bar bending visualization in the project implementation.
Are you using any specific project software, sir?
Tekla we have tried, sir, earlier, but we are confident or not confident on that. Is there any real implementation of Tekla 3D in the rebar detailing for the real life projects?
Sir, I may have to do little more homework to answer this question, sir. So particularly, I have taken a quick note of this, sir. So, sir, your good name is Mr. Narasimha Rao, sir.
Yes, sir. My name is Dr. Narasimha, sir.
Okay, sir. I will revert back to you, sir, on this point. If
Right.
anyone have an idea, kindly request you to answer to Mr. Narasimha Rao.
Hello. I think CAD-SRC is one software where it can allow us to do this reinforcement detailing much easily, to my knowledge.
Tekla is also doing, sir. 3D modeling is doing. But
That is
what
Tekla. I think Tekla is for your steel detailing, probably more of the tools and all. But specifically reinforcement detailing, reinforcement detailing, CAD-SRC software will helpful.
Yeah, for the 3D point of view, I'm asking, sir. Is it helpful?
Correct. Like, I mean, some of the projects actually where like we do bridge projects where all the reinforcement and pre-stressing cables and everything we will model in CAD-SRC. So I think for us, to my knowledge, CAD-SRC is the one of the software where it helps us to model that reinforcement detailing 3D.
Right, sir. Thank you.
I think I think this is the right time. I think this presentation probably there are many youngsters and young engineers are also attended this presentation. I don't know because I am in industry, so I know the role of this presentation, because unless now clients all big projects everywhere, without this digitation, without this BIM, nobody is going to survive in the industry. I think probably to my knowledge, Krishna Reddy Garu, you have successful in, I think, so much information you have given. Probably if you can share this recording session, because a lot of terminology is new to many of us. So probably if you allow us to repeatedly listen this recorded session, it will help us to understand more and more technical terms and then explore in detail during our personal time. Is it possible, sir?
Sure, sir. Fortunately, we recorded this session with the help of the organizers. I will let it distributed to all of you, sir.
Yeah,
Sir,
because
one more-
I have seen it is so much information is covered. I mean, it's not for anybody when he is at the early stage of learning this BIM. It is really difficult for him to note down all the points. Probably recorded session really fill that gap.
Satyan Garu, all our ACCE
Yes, sir.
Kakinada Center presentations are in YouTube, sir. ACCE Kakinada YouTube channel is there. In that, all these recorded sessions will be available.
Thank you, sir. Thank you, sir. Sundar. Thank you. I think.
Yeah.
Sir, good morning.
Since
Yes.
starting,
This
since
is B.R.
starting,
Naidu from Tirupati.
yeah.
Can I go ahead?
Yes, sir. Sure, sir.
Yes, please.
Yeah. See, what will be the cost impact of a BM if mid-time, 3-tier cities to be adopt for this, sir, particularly the consultants?
Sir, for one of our projects, we have paid 2 rupees per SFT. For architectural and plumbing MEP and architectural integration, we paid 2 rupees per SFT, sir.
So they integrated and they give us the project to us, or they implement us?
No, they have given implemented drawings to us and one video presentation also to the client, so that whenever there are overlaps, we had a discussion in the initial stage itself, that is before commencement of work itself, and we made the changes, and ultimately we are very successful. It is for a hospital project, we did it.
Yeah, that's also, I'm also looking for an hospital project in Bangalore where I can convince the client to go for it. But only thing is how costly it is going to be there. Let me know is, suppose, as I said, if implementation is not there, implementation is not part of the vendor, then suppose if any correction comes in during the execution of the project, who is going to attend for that?
They will attend. that is actually because of it's a new thing. The client, the consultant which I hired, he has given me a chance to coordinate with me till the project completion.
Yeah, that's good. That's where we need to have that commitment. Then only we can do it successful project. Otherwise, it is going to be halfway. We have to let it.
Yeah.
Sir, I'm
Thank
Murli
you.
from speaking. Krishna Reddy Kovvuri, it's a nice presentation. I need to learn one thing, whether it can work in the GIS environment also.
Yes, sir.
It is applicable, sir, obviously.
Yeah, if it is applicable, so then why the government is not coming forward to use BIM in its projects?
Sir, it is, I mean, they're using, like Sundarrao sir already mentioned earlier. So, there are in different implementation drawings and other places they are using, but slowly governmental push will also be there, sir. It's actually an advanced technology compared to CAD. We hope with all these awareness and other activities over the time, this will also come in, sir.
Sir, if you go through GO number 119 for the APDMS plans process, shortly means may take 2 or 3 years. BIM implementation is also becoming a part in the while submitting the plan itself. You have to submit your BIM modeling also. That will take place shortly. Like ECBC certification, initially they started with 3,000 square meters and above constructions. Now they made it to 1,000 square meters and above constructions. Shortly, they are going to implement it for G+2 constructions. Likewise, the government will make implementation of BIM for the projects. Initial stages, they may start with projects of size more than 3,000 square meters or 10,000 square meters of plinth area, something like that. And thereafter, they may implement slowly for the small projects also. Thereby, the nation's money will be saved. Why? By implementing the BIM modeling, nation's money will be saved. And cutting and repairing the new construction will not take place. So
Yes,
implementation will take place shortly because there is acute shortage of BIM modeling people. That's why it is not strictly implemented right now. But within 5-6 years, it will be going to have good impact on construction.
Yes, very good, sir. I think it's a good initiative, maybe from the government side or people like you.
Sir.
Because the construction will be in a qualitative mood.
Yes,
maybe
sir.
after 3 or 4 years.
Yeah, definitely.
Thank you, sir. I think we look forward for the next sessions
Yeah.
in the similar.
Definitely, sir. We are almost for last 28 months. Every month we are conducting one webinar or physical event.
Yes.
All are technical events with new technology and emerging technologies, so that our members get benefited with it, and we try to get updated all our members, sir.
Yes. Thank you, sir. Thank you.
Any questions, sir?
Sir.
Sir, Chairman, sir, shall we conclude the program, sir?
Sir,
My vote of thanks.
sir, any more questions, sir? Okay, sir. Our
Hello, sir.
ACCE headquarters election process is in progress. I request all members who have not yet voted, please vote and make it 100% voting center as Kakinada Center.
Yes, sir. I am concluding the program with my vote of thanks. I would like to thank ACCE Bangalore for the program, for the support in this program organization. I would like to thank our center chairman for identifying and mobilizing such a nice speaker. I would like to thank our Kakinada members, engineers, student participants for their valuable participation. My sincere thanks to today's speaker, Krishna Reddy Garu, for giving such a useful topic to our civil engineers and spending his valuable time to the association. In fact, he exactly closed his session within time by 11:55. Thank you, sir. Thank you very much. I request Krishna Reddy Garu to take a few more sessions on deeply the BIM, if permits. Thank you all. With this vote of thanks, we are closing this session. Thank you all. Thank you, sir.
Sir, Durga Prasad garu, 1 minute.
Yes.
One,
Yes, sir.
one person has raised the hand. Please see, sir. Abhijit Kadali has raised the hand. Sir, Abhijit Kadali, if he is online, please join, sir. And Veerbhadra Rao?
Hello, sir.
Yes, sir.
Good morning, everyone. I'm a student of University College of Engineering, Kakinada, sir. And my question is, can we consider a building which is constructed and planned using BIM technology as a green building? I mean, in BIM technology, it is said that there is a greater reduction in energy consumption and there is a frequent monitoring of energy. That's why I'm asking this question. Can we consider the building which is designed using BIM technology be a considered part of green building?
No, your question is not clear, but the answer is suppose plan is prepared by one engineer, elevation is done by architect, interior is done by interior designer, plumbing drawing done by MEP consultant, air conditioning drawing designed by MEP consultant, and plumbing drawing is done by MEP consultant. So there are so many agencies involved. The energy efficiency depends on the selection of materials by the client and the consultant. Whatever the materials they have selected, whatever the technologies they have selected, they will be implemented. It is a technology which can coordinate with each other, but it won't give directly the energy efficiency. What it can give the energy efficiency is it will avoid the repetition of work, dismantling of work. Such things can be avoided by using BIM, but it will not directly give the energy efficiency or anything else. Everything depends on individual parameters which were designed by the consultants. It is it's a grouping, almost like it's a management system.
Okay, sir. Thank you, sir. I got your point.
Yes. Any more?
Hello. Good evening. Good afternoon, sir.
Good afternoon. Good afternoon, sir. Please raise your question, sir. Krishna Reddy Garu is online. He will answer your queries, sir.
Only one small request is after this session, I would like to request you please conduct a live session of with small project at least, so that possible to 1 or 2 days at Rajahmundry or Kakinada or if at Vijayawada, we will participate definitely, sir.
Definitely, we will make it at Kakinada, sir. We will announce the date.
It is a real-time project. Is there? It's very useful, sir. If you want, you can make it membership fees, otherwise anything. But very useful it will be.
Definitely, we had done one project at Kakinada. That project, I'll ask the MEP consultant who has done this BIM work for us, so that he can express his experiences directly. It will be highly beneficial to all of us.
Okay.
Okay, sir.
Thank you.
Thank you.
Okay, thank you, sir.
Thank you. Any more questions, sir? Shall we conclude?
Yes, conclude.
Thank you all for attending the session, and we assure you that we'll give best quality programs always. Thank you very much.
Thank you.
Thank you, sir. Thank you so much, sir.
Thank you so much, sir.
Durga Prasad garu, we can close,
Yes,
sir.
sir. Yes, sir. Yes, sir.
Yeah, I have just one question. Hello.
Yeah.
Yes, if somebody is interested to learn about BIM, is there any facility there at Bhopal?
I don't know, sir. At Kakinada, we want to have one program, sir. That's we are planning. From ACCE Kakinada Center, we want to make a training program, weekend program.
Acha, so you are planning some virtual training program?
Yes, sir.
You are planning some virtual training program, na?
Sir, that we will plan, sir, based on number of.
No, okay. I just want the information about some BIM institutes or BIM centers which may teach about the BIM.
Sir, give me your number, sir. If we are going to conduct it online,
Yes.
we will
My
inform
number.
you,
Yes.
sir.
Please note down. My number is 9425.
1 minute, sir. 1 minute. 9425. Yes, sir.
942580.
Okay.
5222.
Your good name, sir?
My name is DK Parashar. Should I repeat it? 9425.
Yes, sir. Yes, sir. Yes, sir.
5222.
Yes, sir. Yes, sir.
Okay.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay. Thank you.
I give a ring to you, sir.
What is your good name? What is your name?
My name is Durga Prasad, sir, Secretary of Kakinada Center, ACCE.
Okay. So may I know your mobile number also?
Yes, sir. I given a ring to you, sir, already.
Okay. Thank you.
Yes, sir. I will inform you if you are going to conduct online program, sir.
Okay. Thank you.
Yes, sir. Yes, sir. With this program, our members are shown much interest in this program, sir. If you are going to conduct online, we will inform you, sir.
Thank you, Krishna Reddy garu, for
Yes, sir.
your
Thank you,
immediate acceptance and giving a very good lecture to our members. We are highly thankful to you, sir. Thank you.
Okay. Thank you to everybody.
Thank you, sir.
Okay, thank you, sir. Thank you so much for your valuable session, sir.
Yes, sir. Thank you.
Thank you very much, sir.
Thank you so much, Krishna sir, for your valuable presentation on BIM.
Sir, I think Krishna Reddy garu has to close the meeting. Hello? Sir.